Okay, so as I said, and thank you, Joycey, for that very nice introduction. I'm Pierre Fogal. I am what's called the Pearl Site Manager. I work at the University of Toronto. And Pearl is the Polar Environment Atmospheric Research Laboratory. And what Pearl does is it monitors the atmosphere from its location in Eureka, Nunavut, at approximately 80 degrees north. So, to give you an idea of what I'll talk about today, I've got a little bit about me, an introduction to Candac and Pearl, a brief introduction to Eureka and the JAWS HAWS, which I'll tell you about, and then a bit about amateur radio in the Arctic. So, I'm Pierre. Like those other meetings we don't talk about, I'm a ham. I got licensed in Canada in January of 2014. I was first licensed as a ham early in 2000 as Kilo Charlie Zero India Golf Yankee. I have an extra class US license. And then in 2004, we decided to move back from Denver, Colorado, back to Canada. And I did that. I had 3 young kids. I had a new job, a wife who was living in a foreign country because my ex-wife Teresa is American. And so I didn't get back on the air for 10 years. I didn't even think about it. But I got the itch, and so I took the test, and now I'm doing all kinds of things, and I'm not sure my wife's happy about it, but oh well. So I am a local boy. I was born in Guelph, and I did my bachelor's in physics at Waterloo. And then I went south to do my graduate work at the University of Denver. My specialization is in atmospheric spectroscopy. It's not too different from radios. Basically, you have a dipole that interacts with an electromagnetic field, and it absorbs, in that case, the light. So Candac, which is kind of the umbrella organization that runs Pearl, is the Canadian Network for Detection of Atmospheric Change. It's a consortium of Canadian universities and government departments, and in the words of our principal investigator, Jim Drummond, we are a coalition of the willing, which means that we decided we would do this, and then we were looking for money to do it with. Pearl, as I said, is the Polar Environment Atmospheric Research Laboratory, and you can see there, here, this is Ellesmere Island here, Greenland over here, and Eureka is marked by the red balloon. We have 3 facilities that make up Pearl. We have the Ridge Lab, so-called because it's on a ridge. And that was the first one we opened up. And as soon as we opened that, someone said, oh, we'd really like to come up and work there with you guys, but that's too high. We want to be down at sea level. So then we built the Zero Altitude Pearl Auxiliary Laboratory, which we thought would be the end of it. But of course, as soon as we built that, we were told, well, that's too close to everything else. We want to go somewhere far away from things. So then we built the Surface Atmospheric Flux and Irradiance Extension. So Opal, number 2 there, is located at the weather station. The Ridge Lab is about 15 kilometers away by road, and Sapphire is about 5 kilometers away on the north side of the runway. And it's the second most northern facility of its kind in the world. It was the most northern, but they opened up one in Greenland that's just a little bit further north. So if you go up there right now, the sun's not up. The sun goes down the 20th of October. That's a picture at noon on the 20th of October. That's all the sunlight you get. And on the 20th of February, at about noon, you will get that again. Right now, you will get a smudge of twilight on the southern skies at around noon, and that will quickly brighten up to full daylight. Somewhere around April 8th or 9th, the sun will be up 24 hours a day and stay that way until about September 8th or 9th. It's classified as semi-arid. That means that we get a maximum of 30 centimeters of precipitation per year, It doesn't snow a lot there, but I tell you, we see every snowflake that flies in the Arctic and they're all going sideways. So the big red building there is the Ridge Lab, and that's the roof. So this is the business end, if you will, of the instruments. There's an instrument intake here. There is a whole spectrometer in a weather-tight case here. And then through here, there are a number of hatches that open up to allow instruments to take measurements. We added this. This is actually a walk-in freezer that we found up there. But we use it mostly to keep the cold out rather than in. And we have a number of instruments poking through the roof here. This one over here, this is Opal, and it's constructed of ISO standard sea containers. So they're 8 foot by 8 foot by 20 feet, and we modify them and output them so that they are self-contained laboratories. So they're insulated, they're wired for power. We have 3-phase power throughout them, and then we have, you can see here on the side, that's an instrument that comes through the side. The trickiest thing about these things is you need to put in all the holes through the walls that you want when you initially build it. It's extremely difficult to cut into them afterwards. If you use a cutting torch, you're going to set whatever's on the inside on fire. Trying to drill into them or use something like Sawzall just doesn't work. So this is Opal from the other side, and you can see we have a hatch that's open here. We have a LiDAR in there. That's LiDAR is a contraction of laser radar. So in the dark, you would see a beam of green light shooting up through here. And this over here is Sapphire, and it is in a wide open flat area. So there you can see the barn doors on the container, instruments on top. Another instrument rack that's located about 200 meters away, and then this tower here is a 10-meter tall tower, and it's located about a kilometer, maybe a kilometer and a half from the actual container. So we have about 12 instruments on this tower. They measure temperature, pressure, wind speed, and they are sensitive enough that they can basically see the difference in the temperature on the order of about 30 centimeters. The interesting thing about the Arctic is that because the air is so cold, it sinks and it gets layered and stratified. And so you can see a really significant 2 or 3 degree change from the ground up to the top of that tower. From the sea level up to the Ridge Lab, we can have a 20-degree temperature change. So here's a list of our instrumentation that's there at the moment. Don't expect you to read them all. We have 27 different instruments that produce data. This list is actually out of date now that I think about it. We added another 3 back in the fall. But we have spectrometers that measure light. We have radars that measure wind speed, and we have a radar that actually measures the decay of meteor trails. So from that we can deduce the temperature and the pressure at very high in the atmosphere. We have these LiDARs, which are mostly for measuring particles in the atmosphere as well as the temperature. We measure precipitation, wind speed, temperature, pressure, global radiation. That's not radiation in the sense of a nuclear radiation, but in the sense of the fact that since everything has a temperature, everything gives off what we call radiation. Everything gives off heat, and we can measure that energy. Other things that we have there, we have our, it was state-of-the-art weather station. We actually were using the same equipment Environment Canada was using, and we have that located at the Ridge Lab. Now we also have less sophisticated but quite good weather stations at the other 2 locations as well. And we have webcams. If you go to our webpage, you can actually look at the output of the webcams, and Not that they'll show you a whole lot right now since it's dark, but in principle you could. And we keep people there at the moment about 320 days of the year. We were there 365, 724, but when our initial grant ran out, we had to stop that full-time operation. And a subsequent grant wasn't large enough to keep people there all the time. So here's a couple of data sets that are possibly of interest to folks here. So I mentioned that we have a radar that measures the decay of ionization from meteor trails. So these are meteors high in the atmosphere. The lower boundary for them is about 80 kilometers. The upper is about 110 kilometers. And so as these meteors, these are what you see with the naked eye, they streak through the sky, and the light that you see comes from the fact that they are basically burning up. And when they burn up, they leave behind a trail of ionized particles. Ionized particles carry charge, and they decay. And when they decay, the density changes. And so by deducing the rate of decay, we can then deduce what the local pressure is and what the temperature is. And so that then gives us an idea of temperature and wind speed at those altitudes. This then gets used in forecast models to decide what the prediction of atmospheric motion is going to be, which eventually makes its way into your weather. On the other side, we have an optical measurement, and this is actually an aurora stream here. Aurora over Eureka, for whatever reason, are white. They don't have color. They're not green or red or violet as we've seen lots of other places in the world. And what this instrument does is it basically measures the tides in the atmosphere at about 70 to 80 kilometers as well. The atmosphere glows. It's a phenomenon we refer to as air glow. And basically it emits light. And there are tides in the atmosphere, and so you see alternating bands of dark and light for the peaks and troughs of the waves that are the tides. That doesn't show up in this picture because they have to put a lot of data processing into that, and those pictures aren't nearly as pretty as this one. So we produce a lot of data, and we need then a way to move that data. Traditionally, that data got moved on what we call the sneaker net. You fill up a drive and you put it in somebody's bag and they carry it down south. It gets plugged into the computer. That takes, well, if you're really fortunate, you could probably have it about once every 2 weeks, but typically it takes a month to 6 weeks. One of the problems, opportunities, however you want to look at it these days, is that we're expected to provide near real-time access to our data. That's a condition of having received the funding, so that the public, which is you guys, could have access to the data in a day or two. So we needed a satellite link. And we have, as it turns out, the world's most northern geostationary satellite ground station. NFD, which is the satellite we use, is 0.6 of a degree above the horizon. There's basically one place in the area where you can actually see down to the horizon because you look down Eureka Sound. Otherwise, you wouldn't make it because there are too many hills around. But the company that Telesat that built a similar system for the Department of National Defense, they knew where that spot on the island was, and so ours is just a little bit further north than theirs. Hence, we're the most northern. But we have to buy on the satellite the same transponder space that banks, departments of national defense, governments, people with really deep pockets buy. It's the fundamental transponder space. And it's extremely expensive. So we can only afford a certain amount. So for example, the slowest of your DSL lines is going to be about the speed of our link. It'll cost you $30 a month. It costs us $30,000 a month. So in order to get around that, we've been striving for remote operation so that we don't have to do things over the link. The link can then concentrate on moving data. But the most popular remote connection techniques, they require a lot of bandwidth, right? They send a lot of data back and forth. And so, we've tried them all, remote desktop, TeamViewer, VNC. We can do it. It works reasonably well. Until everybody wants to do it at the same time, and then it doesn't work at all. So we restrict the use of that, and we try and insist that people be smart about putting their software together. There are a lot of ways for them to get information back without having to look at the desktop that their computer's running. So why do we do this? The polar regions are incredibly important in global circulation. It's to a large extent, it's about gradients, right? And the gradient in temperature is quite strong from the pole to the equator. And this impacts climate, weather, atmospheric composition. It all is important there. And the polar regions, because there's nobody there, are very much undersampled. And so, understanding the polar atmosphere is critical to understanding the whole global atmosphere. And understanding the global atmosphere then means that we can have a reasonable expectation of predicting the atmosphere. So the best way to measure it is to put state-of-the-art instrumentation at where you need to be to the measurement. That means you need a place like Pearl or South Pole Station. You need to be there in order to see that atmosphere. Of course, there's also the sovereignty, and we all really just enjoy being there because it's a great place. So why not use satellites? I mean, satellites give you global coverage. Well, they do, if they're polar orbiting, which not all that many satellites are. And they actually are complementary to ground-based measurements rather than being mutually exclusive. The kind of dirty little secret of satellite measurements is that we don't believe the satellites until they agree with the ground measurements. Why is that? Well, you build a satellite, often 5 or 6 years before launch. You put it on the satellite, and then you light the candle, and off it goes. It's not a pleasant ride. So your instrument arrives on orbit. With luck, it goes into orbit properly, and with luck, you send the first command, and the solar panels unfold, and the batteries charge, and then you can talk to your satellite. That doesn't happen all the time. And a lot of times, the instruments suffer on the way up. So the instrument you have on the ground, you can get your hands on it, you can test it, you can evaluate it, you have a very good sense of how well it's working. And so when you get it working well, you can take that measurement from the ground and that measurement from space. If they happen to be at the same time in the same place, you can then say, okay, are they the same? Why are they not the same? What's different? And then you come to an understanding of what your satellite instrument's doing. And that's a process that we call validation. It used to be that we would validate satellites after they made it on orbit, and then we would forget about them. They've been validated, of course they work. Well, they don't work the same way as time goes on. So now what we do is, in particular with Canadian satellites, is we validate them throughout time. So now our data set is much better than it ever has been, because as the instrument on the satellite changes, we can compare that to the ground measurements and its previous measurements. And now we understand why it's changing, and we can correct the values where they should be. So Pearl, by virtue of being at 80 degrees north, actually ends up getting more satellite overpasses than most places on Earth. And that's not just Pearl, but anyone on the 80th parallel will be seeing the same thing. So we provide the satellite validation for those instruments. Those instruments in turn provide context for the ground measurements. So we are located at the Eureka Weather Station. And Eureka was one of 5 joint Arctic weather stations, JAWS, established in the late 40s by Canada and the US. When they established Eureka, 3 or 4 guys jumped out of an airplane with a bunch of stuff thrown out after them, and they set up the station, and they didn't land the plane there for some months afterwards. The commander broke his leg on the jump. So it was pretty exciting times. In the 80s, the Americans pulled out of the JAWS system, and Canada renamed them the High Arctic Weather Stations, or HAWS. And they were Resolute Bay, Eureka, Alert, Isaacson, and Mold Bay. Since that point, Isaacson and Mold Bay have both been closed. The others have from time to time been threatened with closure, but thankfully that's never come to pass. So they carry on. There have on occasion been rumors of reactivating Mold Bay, but I think that would probably be too expensive for the appetites of most governments. Eureka is a permanent complement of 8 people. There's the SPM, the Station Program Manager. In years past, he would have been known as the officer in charge. There are 3 weather observers, a cook, a handy person who's responsible for housekeeping and light repairs, a mechanic, and a heavy equipment operator. So their typical rotation is 3 months in, 3 months out. That's not my typical rotation. I kind of get to pick when I go. I keep my folks there at the most for 6 weeks at a time. The difference being that the weather station staff, they work 5 days a week. My guys work 6.5 days a week. They work 8 to 12 hours a day. My guys work 24 hours a day if they need to. So it's a rather different expectation. Alert is a military base, so Eureka serves as basically it's the northernmost accessible location for private citizens. And it's a jumping off point for many expeditions northwards and expeditions to the pole. Usually will leave from Eureka. These days they're not having a lot of luck because the ice doesn't support them. So that's one of the visible issues we see now with the weather warming. And of course, we stay at the weather station. So this is now the weather station building. Who was I talking to before that had been to Eureka? Yeah.
Andy.
The old one, you can just see a bit of the building next to it here. So the old one is kind of right over here. This is on the road opposite, the opposite side of the road. It's quite comfortable. They tell us that they can sleep 48 people there, but that's kind of hard to believe since there's only 2 showers and 2 toilets for the transient folks. The weather station will have the weather station staff have their own rooms and their own bathrooms, which we're quite jealous of. So as I said, the station program manager is the guy in charge. There are 3 people in that position. They rotate in and out. The water supply is provided by snowmelt runoff. It's powered by diesel generators. There are 3 of them. There's one always running. There is one is a hot spare, and there's one generally under repair. Fuel delivery becomes a problem below -48°C. The diesel solidifies. Irving, who usually sells them their diesel, says that that's not possible. So we sent them a picture of this chunk of frozen diesel. Never heard back. So the diesels, of course, produce electrical power. If you're in the mind of complaining about your power bill, we pay somewhere between 8 and 12 cents a kilowatt hour here. I pay 74 cents a kilowatt hour there. Fuel's $5 a liter. There is some automotive gas, there is some avgas, but mostly it's diesel. My cost for accommodation is $360 a day. Yours would be $480 a day. So it's not a cheap place to operate, and it's not a cheap place to visit. So the weather station, among other things, does hourly weather reports for aviation weather. They fly balloons twice a day. These are radiosonde balloons. They are anywhere from a rubber balloon about this big to a plastic balloon, which would be about 2 stories. There's an ozone sonophyte once per week that measures the ozone profile in the atmosphere. And there are then specials which are requested by people such as ourselves or occasionally European groups. And they also monitor the ice and snow depth in the winter. So starting in October, they'll take an auger out onto the ice and they'll auger down, and then they'll measure the thickness of the ice They usually get out there when it's about 20 centimeters thick, and by the time they're finished, it's approaching 2 meters.
Wow.
So HF radio in the Arctic. Now the fun part, for many decades HF radio was the only way to communicate. This is pre-satellite and pre-anything else really. For JAWS, HAWS, and then the DO-line sites. So currently it's fallen out of favor because they want to use sat phones. Have any of you ever actually used an Iridium sat phone? Up there they don't work very well. But that's, you know, they were told by someone down here that this was the thing that they needed. They don't use HF because they don't think anybody's listening. The interesting thing is the Polar Shelf folks who, Polar Continental Shelf Program does support for scientists in Canada that want to go and do field camps in the Arctic. And they maintain contact with all their field camps on HF. So they use a frequency around 4 megahertz, I think it is, for that. So Eureka is also the home of the Northern California DX Foundation, the NCDXF beacon, known as Victor Echo 8 Alpha Tango. It's actually on the air now. We replaced the equipment back in the fall, gave it a new antenna and a new radio and a new controller. So if you're ever wondering whether or not we can hear you up there, if you can hear the beacon, chances are reasonable. It's not guaranteed, but they're reasonable. Since we started operating there, we've logged over 8,000 contacts well, now into our 3rd year. And, you know, we're there somewhere between 10 and 12 weeks a year. The first guy to operate there that was affiliated with us was a guy I was working with who came up from Colorado, Rob Albee. His call sign wasn't AG0DX then, but he's changed it because he's got lots of hidden messages in there. So it was actually him that reminded me that I was a ham when I saw him walking around with his radio and antenna. And there, of course, have been other operations from other stations. Recently, Cesar Trifu, VE3KTBVY0, was up in Resolute last year or the year before, and operated from Resolute before going off to Melville Island. So here's some pictures of my first operating shack, well, literally a shack. I am located in this here. This was once the power room for the station, perhaps 30 or 40 years ago. And now this is basically all garage. So there are large garage doors on either end. Note the chic operating apparel here. Parka, down pants, minus 60C Sorels, polar flakes. All of it was necessary. You can see the beacon equipment, the former beacon equipment in the background here. Note also the piece of pink styrofoam under the desk, which I had to have under my feet because even with the minus 60 boots on, my feet got cold. Because this garage here is where they store the heavy equipment, whenever they were going out to do something, they would open the door and the temperature would drop about 10 degrees because heavy equipment doesn't move that fast. The door's open for a while. It is heated, but the heat can't keep up. So this was February and March of 2014. So after we've been up there for a while, I guess it was 2015, I was joined by Alexei Tikhomarov, who works for Jim Drummond in Halifax. And Alexei had also just gotten licensed here in Canada. He has a Russian call sign. And so between us, and with the assistance of John, I should know his name, VE3KTBVY0, who was a former old-time Eureka operator from the 50s. So he was there when Eureka actually only communicated via HF, and so he was the radio operator. And so the three of us decided we'd form the the Eureka Amateur Radio Club, Victor Yankee 0, Echo, Romeo Charlie. There's a lot of debate about that because when we were thinking about how it would sound in Morse, the various combinations, you know, given the amount of fading and static that we deal with, we weren't sure that you could keep track of where in the call sign you were. So, so we went for this because it's not too bad that way. So we operate from the Ridge Lab. You can see here some of our antennas. We have a 40-meter sloper going off here, a 40-meter dipole going across the, actually that's a 20-meter dipole going across the front, and an R5 vertical here. All of our antennas except for the R5s are homebrew or wire. Here we have a homebrew aluminum Moxon here. This was up for the IOTA contest in the last 2 years. That happens in the summer, and you can see it looks quite different in the summer. And so, yeah, so you know, we like to experiment with antennas like we all do, and because getting things in and out of there can be challenging, and blending is challenging. We've done mostly with wire and homebrew antennas. We did try a wire 40-meter Moxon, but that for whatever reason didn't work out. It was strung across the front of this first deck here, so the front of it was over the railing, and then the reflector was back over this railing here. But anyway. And so far we've been low power only. That's for a number of reasons. We're working on acquiring an amplifier, but we also have to worry about not interfering with any of the instruments. We are not permitted to produce any RFI, and we must accept any RFI that's produced by other things. So far it's been not too bad.
What is your low power? How many watts?
100 watts.
100 watts.
Yeah. Nobody would hear us if we were doing anything less.
Don't run QRP then.
No. No. So this is our QSL card, and we've been running mostly SSB. That's basically just convenience. We've done some RIDI, some JT65, PSK31. Both Alexi and I are working hard on our CW to get back to where we would feel confident. You know, I hadn't held the key in 12 years, and I found that I didn't retain as much as I might have hoped. So we're working on that, and that'll help when we can. And as I said, we've had over 8,000 QSOs since beginning in 2014. So just give you a bit of a photographic tour of the other things of interest. We have one of the world's most studied wolf packs in the neighborhood, and they are not afraid of us, and we are a little bit afraid of them. But they are not, they've never threatened us. It's just that, you know, we got 8 to 12 large dogs running around, and they might be hungry. We have muskox. And these two are basically have split themselves off from the herd. In the fall, you can see herds of hundreds of them, which is truly an amazing sight because they are quite robust animals. There's one of my favorite shots that I've had from up there. We also have caribou. Peary caribou in this case. When I talk to kids at school, I tell them that just off the picture here, there's a sled. And I can't say anything more.
Beautiful.
There are a surprising number of birds up there. This is a snow bunting. They migrate in and out, and he's got his eye on me because I'm watching him trying to land for his nest. They've been nesting in the pockets of the sea containers. A lot of Arctic hare. Not as many as there used to be. The first few times I was out there in the 90s, the white in the background here, which is snow in this picture, would have been hare in those pictures because there were just so many of them. And they are, of course, their populations out of phase with the wolf population. So when there are a lot of hare, then the wolves feed really well. And when they fed too well, then there aren't so many hares. There are also foxes. So the fox is, of the animals there, the only one that actually changes color summer to winter. So you have the summer fox there on the right, the brown one, and the winter fox on the other side. The foxes, they eat hare, and the hares are about the same size as the fox. A lot of flowers in the summer, daisies here, and this is the flowering willow. So this is what passes for trees in the high north. They might make it as high as your ankles. And then we have poppies. And of course we have ice. The water does generally open up around June and stay open until September, which is a good thing because most of the provisions come in on a Coast Guard ship during sea lift about once a year. That includes food, anything that's too large to be flown, dry goods, and fuel. All the fuel comes in out of the bunkers of the Coast Guard cutter. A bit more ice. This is before the water's actually opened up. What you see there is melt pools on top of the ice. And these are the antennas of one of the radars. So this radar has 64 Yagis cut for just under 6 meters, and they're all pointed straight up. And they work by, you have part of the array transmit and part of the array listen for echoes off of the turbulence in the atmosphere. And they can detect turbulence on the order of somewhere between 1 and 2 meters. So that's what I have for you. Thanks very much. I'd be happy to take any questions.
Good.
Why is there a lack of solar power and wind power?
Mostly because we haven't tried yet. Solar power would work quite well for about 6 months of the year. Wind power, the winds can be really horrific, and most wind generators like a nice steady, what is it, about 20 kilometer an hour wind, and so they wouldn't survive. But we're actually looking at attempting solar power up there.
The section where you were talking about media flux and the graph that you had where you're reading media flux.
Yeah.
Is that available to us as this reading? And would that reading do us any good in predicting meteor scatter?
Probably not. Well, I mean, if you had one around here, yes, it would. But that one there would probably not help you with predicting meteor scatter from here. But that data is in principle available. Problem is, it's probably not available fast enough for you to make use of it for that. Because even if it's 10 minutes old, it's probably too old to help.
Well, is that being done in around here somewhere? That type of
There might be one down around London, a place called Harrow. I don't remember which of the two radars he's got there. The guy that builds these is based out of Western Ontario.
Is that where Exeter Radar is at?
Yeah,
Okay.
yeah. Well, somewhere in that area, yeah.
Is there any impetus for the weather station to monitor the yearly CO2 levels for climate change like they do at Mauna Loa?
We do actually measure that, yeah.
Oh, you do, yeah.
Yeah.
And do you find a correlation with the Hawaiian data as well?
I can't actually say. I haven't looked at it myself. And it's one of those things that you would think somebody would be really interested in, but apparently no one's picked it up.
And also Pierre, you guys are gonna run Islands on the Air this summer? or
Yeah.
next-
Well, hopefully if we're there, yeah.
All right, all right. Because this is our island chaser right here.
Thanks, Whenabouts do you run that in the summer for? Is it the IOTA
Well-
contest?
Well, we've been on for the contest for the last
Okay.
2 years,
Yeah.
but I mean, any contact with us will count for.
We'll count for the
IOTA.
island, yeah,
Yeah.
yeah, for sure.
And
Looking for you.
Alexi's been up there since Saturday. He got on the air Monday. So the Whisper, he's been running the rig as a Whisper beacon for the last 2 or 3 days. So yeah, if you can hear him, go ahead and work him.
For sure.
If not, I'll be there on the 24th, and if you can hear me, same thing.
Do you maintain any sort of a schedule?
Well, we try, but you know, the issue is that we're a long way from the radio if we're not, you know, at the lab. We have been working on remote communication or remote control of the rig, which works pretty well. But you know, we have to work, so that tends to mess up most schedule attempts. You know, if you want a schedule and you send VY0ERC@gmail.com, send an email, we will attempt a schedule, and hopefully it works. If propagation is in our favor and time and all that, then you know, we'll certainly get it done. We try to work all the major contests if we're there for one, so we'd love to have you work us during a contest. You know, even if you're not in the contest yourself, this still counts for us. So, absolutely.
Is there any challenges with running diesel up there because of your instruments? Obviously, they're fairly delicate and the diesel generator power can be really,
Yeah, so we don't run a generator at the Ridge Lab. We have a 15-mile long extension cord. With 2 step-up transformers along the way. So it's pretty clean. It's also on the hill means that, because the way the atmosphere stratifies, that most of the crap stays down below us, and so it doesn't get into those measurements. We do have some of the instruments at Opal that I had to stop one group from making great pronouncements on what they were doing, because I said, I think you're seeing diesel smoke. And they said, oh, no. And I said, well, you might want to check. And they did check, and yes, they were seeing diesel smoke.
yeah, there's a challenge with the exhaust plus possible dirty power and so forth, right?
Yeah. It adds a lot to the turbidity of the atmosphere locally.
Yeah.
So that's, which is what they were measuring. They thought they had a new mode for particles in the atmosphere.
Have to run a natural gas line up.
Any chance you'll be running a pointing vector antenna up there?
Oh, well, we've been talking to, you must know Paul.
Oh, yes.
Paul asked the same question.
We offered to take an antenna up for Paul, and he then talked a little bit about the weather, and so he's not sure it'll survive, but you know, when he's got one that he feels he wants to try out there, we're certainly willing to try.
It'd be pretty interesting to see what its comparison of performance is like.
Yeah,
And,
yeah. Any kind of antenna experimentation, we're happy to try. You know, assuming we can.
you see that one?
What is that?
That's a 2 meter 440 log periodic antenna. It's a 2 meter antenna with the third harmonic tuning for 440.
Okay,
And the spacing is for 440, but the elements are for 2 meters.
and it works well.
10 dB front gain and 20 dB front to back ratio.
Okay.
It's
Of course, you still won't hear us.
not at that frequency VHF. I'd love to hear you on VHF up there.
Yeah, and a lot of people would. They shouldn't believe it.
Yeah, I don't think so.
You ever need an extra cook or a mechanic?
Okay, I'll pass your names to ACCO.
That'd be a great vacation, 3 months in the Arctic. Oh!
Well, it's all right if you pick the right 3 words.
That's right.
What bands do you predominantly like to use? 40 mostly?
20 has been our bread and butter.
Has it? Okay.
20 has been the
Good.
one that's in the most.
Just have to
We
get-
think that we ought to be able to do well on 40, except that every time we try, we haven't done so well. And we don't really understand why. We would think that during the winter, 80 would be really good too, but when we've tried 80-meter antennas, I mean, they're a challenge physically to get a good one, but we haven't had any success on 80. We had some success on 40.
We're building a prototype 80-meter PV antenna, which we'll do some playing with, but that would be substantially smaller than anything we have there.
Yeah, I would, yeah.
And,
No, like I said, if you got something you want to try, we're happy to do that.
yeah, well, we'll see what happens with this first. This is all speculation at the moment.
Do you have a favorite frequency on 20 that you
No,
cruise around?
we'll get on, we'll try with, and start it with the iota frequency at 14,260. But there's usually somebody parked on there having a rag chew
So you
with,
kind of go up and down?
yeah. But wherever we can find a hole, we'll pop up. And we tend to get spotted pretty quickly, so if you're watching the clusters, you'll see us.
I'll point my beam up that way.
That tends to be the biggest challenge, is nobody points their antenna that way.
Exactly. That's interesting. That's a fascinating challenge to be up there. So how often do you get up there?
About 3 or 4 times a year.
Wow. Are you up there in the dead of winter also?
Yeah, I'll be heading up in a month.
It'll still be the dead of winter up there,
Yeah.
won't it? Yeah.
Do you ever take university students up with you as part of the research?
Yeah.
or-
That's who's going with me in February, and most of the February trips are with students.
Cool. It's a great opportunity for them.
Well, we like to think so.
Yeah.
You'd have to ask them if they feel the same way.
When it's over with, right?
Yeah, because I mean, they have to put up with me for 3 weeks, so.
Hey kid, go feed the wolves.
Did you do any fishing for Arctic char at all?
And I have not. Those that I've talked to that have tried have not caught anything.
Okay.
The char is a freshwater fish, I think, or no? maybe
Yeah, it
not.
is.
Is it?
Yeah.
So what appears to be in the fjord are something called Arctic cod,
Yeah.
and there's not a lot of them.
That's nice, sweet.
And that's good, because that means no seals. No seals mean no bears.
Are there any women up there?
Yes.
Food chain, right?
Food chain right there.
I'm taking 4 up with me.
Excellent.
And there's usually,
Yeah.
well, currently I think there's 3 on the weather station staff as well that are up there. But there are times when there are more women than men.
Oh, interesting.
Does the Aurora play havoc with the equipment and instrumentation?
We are dead center of the auroral oval, and so it doesn't affect us the way you might think with precipitation of electrons and things like that. But of course, every signal in and out goes through the belts, and so attenuation is a big problem.
I know with the ozone hole over the South Pole, is there a similar or comparable hole over the North Pole as well?
There is.
You never hear about it.
Well, you didn't read our paper. In 2011, there was actually quite a large one over the Arctic, and we made the news for 10 minutes that day. It's not as deep as the one over the Antarctic because it's not as cold, and it's not as cold because the Arctic is mostly water and the Antarctic is a landmass. So yes, there is one, and every year we go up when one should happen, if it's going to happen, in hopes that it will happen, and then we'll have something interesting to look at. But 2011 was the last one of any significant size.
Can you explain that?
Explain
What is it?
the ozone hole.
Yeah.
So there's a kind of cloud that forms over the polar regions called a polar stratospheric cloud. And these are ice clouds, and the crystals are made up of a combination of nitric acid and sulfur and other little bits of stuff. And these ice particles provide a surface for chemical reactions to happen on. So so it's a catalytic reaction. And what it does is it releases chlorine, the chlorine that's tied up in other molecules like hydrochloric acid or chlorine nitrate or things like that. And once that chlorine's been released from the molecule, then it becomes a very proficient reactant, and it reacts very quickly with the oxygen and ozone. And when it reacts with the ozone, it converts the ozone into straight oxygen. And so the amount of ozone goes down, and that's what forms the ozone hole. And this is activated basically when the sun comes up. So it doesn't happen in the dark, it needs sunlight. So that's why you tend to get them in the spring when the sun returns to the Arctic or the Antarctic.
And the hole goes in right through the ice?
No, well, it's basically it's a hole in the sense that there is this region of the atmosphere, this layer that has ozone in it, and that layer then has an area where all the ozone is gone, and that's the hole. So it will be from not quite to ground level, but say from about 7 kilometers up to about 50 kilometers.
Sunscreen.
What do the caribou and the hare survive on? How do they survive the winter?
There is a bit of grass under there.
Yeah?
And I mean, they've got to be incredibly efficient animals to survive on what they find, because they sit there and they paw away at the snow, and they nibble and they paw away, and they nibble and they paw away, and they nibble. And they all seem to be healthy. But yeah, there's not much there.
Pierre, has your research taken on Antarctica yet?
Has it?
Taken your research to Antarctica?
I have been there, yes,
Okay.
before coming back to Canada.
Which station?
Yeah.
Which one were you at? Which base?
I was at South Pole Station and McMurdo.
Wow. Well traveled.
Maybe a stupid question, but are there any natives up there?
No.
No, nothing at all?
No. The furthest north community is Grise Fjord. It's about 500 kilometers south.
It's on Bassett.
On Ellesmere.
Ellesmere,
Yeah.
yeah.
Yeah.